Hi, I'm Lisa Martinez, and I'm the student facilitator for the Carbon Fund. The Carbon Fund funds energy reduction projects, renewable projects, anything that reduces energy, waste, or water, usually. Students can get involved in the Carbon Fund through three ways. One, you could be a student staff member. We have an outreach coordinator and student facilitator. Or you could sit on the committee as a student rep, or you could apply for the Carbon Fund, which you can do online at sustainability.ucsc.edu.
Hello, my name's Kevin Green, and this is the greenhouse that I built over the quarter with the Green Building Campaign for the Student Environmental Center, and as well with the Carbon Fund grant for $5,000. So the idea was to build an aquaponics system in here. So we've got our aquaponics fish tank right here. It's 150 gallons. We've got all kinds of different species growing in there to help out with the bacteria and the nutrients that accumulate. And we've got our growing beds over here. So the water cycles up through these, feeds the plants, waters the plants, cycles back down into a sump tank where we're able to add our bio teas and compost teas. And it's a closed loop organic system for food production using off-grid technology with the solar panel, and all our water is harvested from rainwater. And that's basically my project. So another green building aspect of our project was we needed some power to power our pumps and various components. So we developed a solar charging station. This solar panel connects to our charging station down here, which powers any of the electrical components in the greenhouse for monitoring and our pumps. As well, you can charge your laptop or a cell phone here. You can sit here and do your data logging, and we can also play music for the garden, which is pretty cool.
So this project is called Oceanic Scales. This is my MFA thesis project within the Digital Art and New Media program here at UCSC. And this project is all about phytoplankton. It's about how important phytoplankton are to our planet's ecosystems. And it's about the myriad ways that human beings affect phytoplankton's ability to thrive. The other side of this whole project is using renewable and recyclable and biodegradable materials, because there's no point in making an art or science exhibit about ocean health if it's all made out of plastic that's going to end up in our oceans and landfills. And finally, thanks to, in big part, by a grant from the Carbon Fund initiative here at UCSC, we were able to purchase a solar power system for the entire project. So this is a mobile solar panel system. If I roll back the wall here, you can see it's a 100-watt solar panel that can store its energy into a large battery that can produce almost 1,000 watts of electricity for up to 3 or 4 hours. So this is a wonderful component for both this system and future projects that we work on for doing kind of off-the-grid performances and video projects, as well as powering a project like this, which is all about biomimicry.
Hi, my name's Joseph Haggard, and I'm working on my compost water heater here. It was funded through the UCSC Carbon Fund, and I'm really grateful for all the efforts they've been able to put forward towards it. This is using wood chips and manure to basically produce a compost pile that's going to be heated, and there's heat exchange coils coming through it that's going to heat the water. The decomposition from the microbes produces the heat, which goes into the water, and right behind the pile you can see the showers. That's going to be heating for 2 showers for 4 to 6 months, and the apprentices on the farm are going to get to use it. This was inspired by Jean Pain in the 1970s. He was powering his entire farm off of compost. He was heating greenhouses, he was heating his own house, he was heating his showers, and that all can be done with a simple compost pile. So thank you UCSC, thank you Carbon Fund, thank you to all my homies, and let's do this. So I find this type of work really important because right now we're facing a time where our agricultural processes are pretty damaging for the earth, and finding ways to build compost and use it in efficient ways such as heating water can really get people more back towards using compost instead of synthetic fertilizers. Because I think that's really important. It's just being able to compost our food waste and use it for productive things like heating a shower or heating a greenhouse. Right now, UCSC is doing a compost feasibility study, and I really hope that this project can help demonstrate the potential for compost heat recovery on campus. And I really think that this idea not only on campus, but can be used in various places, on farms, in large communities generating large amounts of food scraps, and any school campus for research and education. It's a great thing that we can do, stacking functions and using permaculture design methods.